Here we have a problem on logarithm. Okay, let's go to the question. Find the logarithm of 64 to the base 2 root 2. That is, we have to evaluate log base 2 root 2 of 64. Okay, how do we have to evaluate this logarithmic expression? For that, what I have to do is I have to write this 64 as a power of the base, that is as a power of 2 times square root of 2. For example, I am writing that is a log base 2 times square root of 2. I am writing this 64 as a power of this 2 times square root of 2. For example, I am saying that is 2 times square root of 2 to the fifth power. Okay, when I write this 64 as a power of 2 times square root of 2, now what I can do is in this step I can use the power rule of logarithm. That is, when the argument of a logarithm is a power, so the exponent we have over here can be moved in front of the logarithm and it has to be multiplied by the logarithm. Then we get 5 times a log base 2 times square root of 2 of base 2 times square root of 2. Okay, in this logarithm, the argument is 2 times square root of 2. The base is also the same. In a logarithm, whenever the base and the argument are equal, the value of such logarithm is 1. Then we get 5 times 1. We get 5. In this way, I can evaluate the given logarithm. Okay, so to evaluate this given logarithm, what I have to do is I have to write this 64 as power of 2 times square root of 2. Just for an example, I said 2 times square root of 2 raised to the fifth power is equal to 64, but actually it is not. So now I have to do some calculation to write this 64 as a power of this base 2 times square root of 2. So for that, what do we have to do? We have to decompose this 64 into its prime factor, just 2. Because here in the base we have 2 and we have 2 inside the square root. Okay, 64 is an even number. It can be divided by 2. When I divide this one by 2, I'm getting 32. Again, it can be divided by 2. Then I'm getting 16. Again, it can be divided by 2. Then I'm getting 8. Again, it can be divided by 2. I'm getting 4. Again, it can be divided by 2. I'm getting 2. So now how many 2s I'm getting? 1, 2, 3, 4, 5, 6. So 64 can be written as 2 to the sixth power. Okay, now what I'm going to do is I'm going to write this exponent 6 as 4 positive 2. Further, now let me consider the product rule of exponent, that is a to the mth power times a to the nth power. Here I multiply two terms with the same base a. Whenever I multiply two terms with the same base, what I can do is I can take the base once and I have to add the exponents m positive n. Okay, now let me consider the same product rule in the reverse order. That is, here we can consider stuff on the right side. Here we have base a at the exponent, 2 values are added. Whenever 2 values are added at the exponent, what we can do is we can take this base a separately for each value and multiply the results we have on the left side. The same thing we can do over here because here we have 2 values added at the exponent. Now what I can do is I can take this base 2 separately for this value and this value and multiply the results. Then I'm getting 2 to the fourth power times 2 to the second power. Okay, now let me consider this particular 2, that is 2 over here, and we don't have square root for this 2, but I am taking square root. Okay, so this 2 and square root of 2 are equal? No, they are not equal. Actually, we just have 2, but I have taken square root because I need square root for this 2. For that, I have taken square root. So to balance this square root, what I have to do is I have to raise this stuff to the power of 2. Now, what is the simplification of this one? So here when I simplify this one, this square root and square root cancel out, still this is equal to 2. So for a number, if I want square root, I can take it, but to balance a square root, it has to be raised to the power of 2. So for this 2, what we can write is a square root of 2, the whole square. Okay, let me write it over here. Let me write this one as it is, that is 2 to the fourth power times for this 2, I am writing this stuff, that is square root of 2, the whole square. Actually, I have written this stuff only for this 2. Still, we have this exponent 2 that has to be taken for the complete stuff we have over here. Then we get 64 equals to 2 to the fourth power times here the base is square root of 2. We have exponent 2. For the complete stuff, again we have exponent 2. Whenever we have 2 exponents like this, we can multiply the 2 exponents using the power of a power rule in exponent. Then I'm getting square root of 2 raised to the power of 2 times 2 is 4. So here, two terms are multiplied with the same exponent 4. Whenever we multiply two or more terms are multiplied with the same exponent, what we can do is we can take the exponent in common, and we have to multiply the bases. That is 2 times square root of 2 raised to the power of 4. I took the exponent 4 in common. Okay, now I have written 64 as a power of 2 times square root of 2. That is 2 times square root of 2 raised to the power of 4. Okay, now let me continue over here. That is log 2 times square root of 2. This 64 can be written as 2 times square root of 2 to the fourth power. So this is a stuff equal to 64. Okay, now we can use the power rule of logarithm. That is, if the argument of a logarithm is a power, the exponent we have at the argument can be moved in front of the logarithm, and it has to be multiplied by the logarithm. Then we get 4 times log 2 times square root of 2 to the base 2 times square root of 2. Okay, now in this logarithm, the argument and base, both of them are equal. In a logarithm, if the argument and base are equal, the value of the logarithm is 1. So the value of this logarithm is 1, that is 4 times 1, which is equal to 4. Now I got the logarithm of 64 to the base 2 root 2. Its value is 4.